Part 1. The Birth of an Idea. Long before modern computers existed, humans were already fascinated by the idea of creating intelligence outside the human mind. Philosophers in ancient times debated what thinking really meant. Was intelligence something unique to humans, or could it be recreated artificially? These questions lingered for centuries, waiting for technology to catch up with imagination. The real turning point came in the 20th century, when the first electronic computers were invented. These early machines were massive, slow, and limited. They filled entire rooms and required teams of people just to operate them. At first, they were used mainly for calculations, solving mathematical problems much faster than any human could. But some scientists saw something more. One of the most influential thinkers of that time was Alan Turing. He asked a bold and simple question: can machines think? This question would become the foundation of artificial intelligence. Turing didn't just ask the question, he proposed a way to test it. This idea later became known as the Turing test. The concept was straightforward. If a machine could communicate with a human in such a way that the human could not reliably tell whether they were talking to a machine or another person, then the machine could be considered intelligent. At the time, this idea sounded almost like science fiction. Computers were barely capable of basic tasks, and the notion that they could one day hold conversations or understand language seemed unrealistic. Despite the skepticism, the 1950s and 1960s marked the beginning of real experiments in artificial intelligence. Researchers began creating programs that could solve puzzles, prove mathematical theorems, and play strategic games like chess. These early systems followed strict rules and logic, but they represented something new: machines performing tasks that required a form of reasoning. There was a wave of optimism. Many scientists believed that truly intelligent machines were just around the corner. Governments and institutions invested heavily in research. Universities opened new labs dedicated to artificial intelligence. The future seemed close, almost within reach. However, the excitement soon met reality. While these programs were impressive, they were also extremely limited. They could only operate within narrowly defined environments. A chess program could play chess, but it couldn't understand language. A problem-solving system could follow logic, but it had no awareness or intuition. Machines didn't understand what they were doing, they simply followed instructions. Even simple tasks that humans perform effortlessly, like recognizing objects, understanding context, or interpreting emotions, were incredibly difficult for computers. Researchers began to realize that human intelligence was far more complex than they had initially assumed. Still, this early period was crucial. It laid the groundwork for everything that would come later. Concepts like algorithms, symbolic reasoning, and early learning systems were developed during this time. Even though the results didn't match the expectations, the foundation of artificial intelligence had been established. What started as a philosophical question had turned into a real scientific field. And although no one at the time could fully predict it, this idea, the idea of creating thinking machines, would go on to reshape the world in ways far beyond imagination. Part 2. The First Winter and Hard Lessons. After the early excitement and bold promises, reality began to set in. The progress in artificial intelligence was much slower than researchers and investors had hoped. What once seemed like a near-future breakthrough started to look like a distant dream. In the 1960s and 1970s, many AI systems showed potential, but only in very controlled environments. Programs could solve algebra problems, play chess, or prove logical theorems, but they struggled the moment anything changed. A small variation in input could completely confuse them. These systems didn't truly understand anything. They relied on rigid rules written by humans. If the rules didn't cover a situation, the machine simply failed. This limitation became a serious problem. Governments and organizations that had heavily funded AI research began to lose confidence. They had expected intelligent machines within a few years, but instead saw slow progress and repeated obstacles. As a result, funding was cut, Projects were canceled, and many researchers left the field. This period became known as the AI winter. One major issue was the lack of computing power. Early computers simply weren't strong enough to handle complex tasks like vision, language understanding, or real-world decision-making. Problems that seemed simple for humans required enormous amounts of processing for machines. Another challenge was the approach itself. Early AI focused on symbolic reasoning, trying to describe intelligence using logic and explicit rules. But human thinking doesn't work like a strict rulebook. People learn from experience, adapt to new situations, and make intuitive leaps that are hard to define mathematically. Researchers began to realize that intelligence wasn't just about logic, it was also about learning. There were also famous setbacks that damaged the reputation of AI. Early machine translation systems, for example, failed to produce accurate results. Language turned out to be far more complex than expected, full of context, ambiguity, and cultural meaning. This led to skepticism about whether machines could ever truly understand human communication. Despite the disappointment, this period was not a failure, it was a lesson. Scientists started to rethink their strategies. Instead of trying to program intelligence directly, they began exploring ways for machines to learn from data. The idea was simple but powerful. Instead of telling a machine exactly what to do, let it figure things out by analyzing patterns. This shift in thinking would later become the foundation of modern artificial intelligence. Even during the winter, important work continued quietly. New theories were developed, better algorithms were designed, and researchers gained a deeper understanding of what intelligence really involves. The field had lost its early hype, but it had gained something more valuable: realism. Artificial intelligence was no longer seen as an easy problem. It was recognized as one of the most complex challenges in science and technology. And although progress seemed slow at the time, these hard lessons were exactly what AI needed to move forward. The winter would not last forever. Part 3. The Rise of Learning Machines. After years of disappointment and reduced expectations, artificial intelligence began to quietly evolve. Researchers had learned an important lesson during the AI winter. Intelligence could not simply be programmed with rules, it had to be learned. This shift in thinking changed everything. Instead of telling machines exactly what to do step by step, scientists started developing systems that could learn from data. This approach became known as machine learning. The idea was simple in theory: feed a computer large amounts of information and let it find patterns on its own. At first, progress was slow. Early machine learning models were limited and required carefully prepared data. But as computing power gradually increased and more digital data became available, these systems began to improve. One of the key concepts that reemerged during this time was the idea of neural networks. Inspired loosely by the human brain, these systems were designed to simulate how neurons connect and process information. The idea itself wasn't new. It had existed since the mid-20th century, but only now did technology begin to catch up with the concept. Among the pioneers who helped revive interest in neural networks was Geoffrey Hinton. His work, along with others, showed that neural networks could be trained more effectively than before. This led to the development of deep learning, where networks contained multiple layers that allowed them to recognize complex patterns. Unlike earlier rule-based systems, these new models didn't need explicit instructions for every situation. They learned by example. For instance, instead of programming a computer with rules like a cat has 2 ears, 4 legs, and whiskers, researchers could show the system thousands or even millions of images of cats. Over time, the machine would learn to recognize what a cat looks like on its own. This was a huge breakthrough. Suddenly, problems that once seemed impossible, like image recognition, speech processing, and natural language understanding, became more manageable. Machines started to improve not because they were given better rules, but because they were given more data. The rise of the internet played a massive role in this transformation. It provided an almost endless supply of information: images, text, videos, and user interactions. This data became the fuel for machine learning systems. At the same time, hardware improvements, especially the use of GPUs, graphics processing units, allowed computers to process large datasets much faster than before. What once took weeks could now be done in hours or even minutes. However, this new approach also introduced new challenges. Machine learning systems depended heavily on the quality and quantity of data. If the data was biased or incomplete, the results would be flawed. Unlike rule-based systems where every step was clear, these models often acted like black boxes. They produced answers, but it wasn't always obvious how they reached them. Still, the benefits were undeniable. AI systems began outperforming humans in specific tasks. They could recognize speech with increasing accuracy, recommend products, translate languages, and even beat world champions in complex games. The field of artificial intelligence was no longer in decline, it was accelerating. What had once been a struggling idea was now becoming a powerful technology, reshaping industries and redefining what machines could do, and this was only the beginning. Part 4: The Breakthrough into Everyday Life. By the early 2000s, artificial intelligence was no longer just a research topic, it was becoming part of everyday life. What had once existed only in laboratories and academic papers was now being used by millions of people around the world, often without them even realizing it. The key driver of this transformation was deep learning. With better algorithms, more data, and powerful hardware, AI systems began achieving results that were once thought impossible. One major milestone came in 2012, when a deep neural network dramatically improved image recognition accuracy in a well-known competition. This moment showed the world that AI could outperform traditional methods by a huge margin. It wasn't just progress, it was a leap forward. Soon after, companies started integrating AI into real products. Tech giants like Google, Apple, and Amazon began using AI in their services. Search engines became smarter. Voice assistants could understand spoken commands. Recommendation systems started predicting what users wanted before they even searched for it. For example, voice assistants like Siri and Google Assistant made it possible to interact with technology using natural language. This was a huge shift from typing commands to simply speaking. At the same time, AI-powered recommendation systems changed how people consumed content. Platforms could suggest movies, music, and products based on individual preferences. This made digital experiences more personalized, but also raised questions about privacy and control. Another major breakthrough came in 2016, when an AI system developed by DeepMind defeated a world champion in the complex game of Go. This achievement shocked many experts because Go had long been considered too difficult for machines due to its enormous number of possible moves. The victory showed that AI could handle not just structured problems, but also highly intuitive and strategic ones. AI was also transforming industries beyond tech. In healthcare, systems began assisting doctors in diagnosing diseases from medical images. In finance, algorithms analyzed markets and detected fraud. In transportation, early versions of self-driving cars started appearing on the roads. However, as AI became more powerful and widespread, concerns also grew. People began to worry about job displacement. If machines could perform tasks faster and more efficiently, what would happen to human workers? There were also ethical concerns: how decisions were made, whether systems were fair, and how much control humans should retain. Despite these challenges, the impact of AI was undeniable. It was no longer a distant vision or experimental technology. It had become a tool, one that people used every day, often without even thinking about it. Artificial intelligence had crossed an important threshold. It was no longer just learning, it was living alongside us. Part 5: The Age of Generative Intelligence. As artificial intelligence continued to evolve, a new and powerful direction began to take shape: generative AI. Unlike earlier systems that focused mainly on analyzing data or making predictions, these new models could create entirely new content: text, images, music, and even code. This marked a major shift. AI was no longer just a tool for solving problems, it was becoming a tool for creativity. One of the biggest breakthroughs came with the development of large language models. These systems were trained on massive amounts of text from books, websites, and other sources, allowing them to understand and generate human-like language. Suddenly, machines could write essays, answer questions, tell stories, and hold conversations in a way that felt natural. A key player in this transformation was OpenAI, which developed systems like ChatGPT. These models demonstrated how far AI had come. They could assist with writing, learning, coding, and problem-solving across a wide range of topics. At the same time, image generation tools such as DALL-E allowed users to create detailed visuals simply by describing them in words. This opened up entirely new possibilities for artists, designers, and creators. Generative AI quickly spread across industries. Writers used it to brainstorm ideas. Programmers used it to generate code. Businesses used it to automate communication and content creation. Students used it as a learning assistant. The barrier between idea and execution became much smaller. What once took hours could now take minutes. But with this power came new questions. If AI can create content, who owns it? If AI can write like a human, how do we know what's real? If AI can generate information instantly, can we always trust it? There were also concerns about misinformation. Generative AI could produce highly convincing text or images, which made it easier to spread false or misleading content. This forced society to rethink how information is verified and trusted. At the same time, many people were amazed. Positive reactions poured in. AI made work faster and more efficient. It helped people learn new skills. It supported creativity rather than replacing it. It gave individuals access to tools that were once limited to experts, but not everyone was comfortable. Some feared that AI would replace creative jobs. Others worried that relying too much on AI could reduce human skills over time. There were debates about ethics, responsibility, and the long-term impact on society. Still, one thing was clear: generative AI had changed the relationship between humans and machines. For the first time, people weren't just using AI to analyze the world. They were using it to create new things together with machines. The line between human creativity and artificial intelligence was beginning to blur. And this raised an even bigger question. If machines can create, what role will humans play next? Part 6. The impact on society. Today, as artificial intelligence became more advanced and accessible, its influence on everyday life grew rapidly. What once felt like a futuristic concept had fully entered the present. AI was no longer something people only heard about, it was something they interacted with constantly. From the moment people wake up to the time they go to sleep, AI is quietly working in the background. Smartphones suggest messages before you finish typing. Navigation apps predict traffic and choose the fastest route. Streaming platforms recommend movies and music based on personal taste. Much of this is powered by AI systems developed by companies like Google and Meta. In the workplace, AI has become a powerful assistant. It helps analyze large data sets, automate repetitive tasks, and improve decision-making. In fields like medicine, AI supports doctors by identifying patterns in medical images and suggesting possible diagnoses. In education, it acts as a personalized tutor, helping students learn at their own pace. For many people, AI has made life easier and more efficient. Tasks that once required hours can now be completed in minutes. Information is more accessible than ever. Creativity has expanded, with tools that help people write, design, and build without needing years of training. Positive feedback continues to grow. People appreciate how AI saves time. They value the support it provides in learning and problem-solving. They enjoy the convenience and personalization it offers. However, alongside these benefits, there are serious concerns. One of the biggest fears is job displacement. As AI systems become more capable, some roles are being automated. Jobs involving repetitive or predictable tasks are especially at risk. While new opportunities are being created, the transition can be difficult for many workers. There is also the issue of trust. AI systems are not perfect. They can make mistakes, produce incorrect information, or reflect biases present in the data they were trained on. This raises important questions. Can we rely on AI decisions? Who is responsible when something goes wrong? Privacy is another major concern. AI often relies on large amounts of data, including personal information. Many people worry about how their data is collected, stored, and used. Criticism of AI has become more vocal. Some say it reduces human independence. Others believe it can spread misinformation. There are concerns about ethical use and lack of transparency. At the same time, others argue that these challenges are not reasons to stop AI, but reasons to improve it. Governments, researchers, and companies are now working to create rules and guidelines for responsible AI use. The goal is to ensure that AI benefits society while minimizing risks. Despite the debates, one thing is undeniable. AI is shaping how people live, work, and think. It is not just a tool anymore. It is becoming a part of the environment in which modern life exists. And as its role continues to grow, society faces an important challenge. How do we use this powerful technology wisely? The answer to that question will define the next chapter of artificial intelligence